when we integrate, we're finding the area to the x-axis. So if we have a top curve and we have a bottom curve, and they could be different, they don't have to be exactly the same. We're finding the area under this curve, but it's to the x-axis. So we're finding all of this area right here, under the top curve. Then, if we subtract out the area under the bottom curve, what's left is the area in between the two curves. If we look at number 5 here, we're going to find the area under 2x squared. We're going to subtract out the area under that curve. We're going to go from 0 to 2 because these are even functions. They're both even functions. They have even powers. 2 is even, 4 is even, 2 is even. But the question you might have is, all right, well, we're subtracting out this little triangle-ish area, but I don't want to subtract out this area because that's still area under this curve. And I know technically under means below, but in math, under the curve means to the x-axis. So we want to kind of add that area on to the x-axis, but don't worry, because that little area is negative. And if you minus a negative, it's adding the area on. So the good news I have for you is you don't have to worry about stuff that's below the x-axis or above the x-axis. That is not an issue. The math will take care of that. Yeah.
What if there's area below the x-axis and it's part of the first?
That's fine. It'll all work out, believe it or not. Yep. Well, let's do the math on it. Once again, I've determined that this is truly an even function. Both of them are even, and it is the same on both sides. When that happens, I like to double the area and just go from 0 to 2 rather than going from -2 to 2. The reason we want to do that is it's much easier to plug 0 in. There's a better chance of making a mistake by plugging -2 in than plugging 0 in. Now you do have to be a little careful with that because the cosine of 0 is not 0, and e to the 0 is not 0. So those are the times where you have to be a little bit careful. But most of the time when you plug in 0, it's going to be 0. That's good news. All right, top function, 2x squared, minus the bottom function, x to the 4th minus 2x squared. Unfortunately, we are minusing. And with minusing, you have to be careful with the signs. So a lot of places where you have to be careful. All right, we have 2 times integral from 0 to 2 of 4x squared minus x to the 4th dx. We're going to integrate the polynomial now. We have 2 times 4/3 x to the 3rd minus 1/5 x to the 5th. That's going from 0 to 2. 2 times. 2 to the 3rd is 8. 8 times 4 is 32. So 32/3 minus 2 to the 5th is 32, by coincidence, over 5. And if I minus out, plug in 0, you get 0 on both. Now, very careful to look and see, do I get 0 when I plug in 0? Yes, we do. 2 times, how about some common denominator? 160 over 15 minus 96 over 15. 2 times 64 over 15. So 128 over 15. Hopefully by now, integrating polynomials is very easy for you. So with that being said, if you want to use your calculator, I want to see this. I want to see this much right here. If you want to use your calculator for polynomials after that, that's up to you. If you need more practice integrating polynomials, you better practice it. If you're like, I'm good, go ahead and use your calculator. I kind of encourage that now. That'll save you a little time on the homework. This is an example where I would use a calculator rather than doing everything by hand, because it's all polynomials, no problem. this is an example of where the top function and the bottom function change places from -2 to 3. So we have to represent that. Now I don't see any symmetry here, so I'm not going to double anything. We're going to start by integrating from -2 to 1. The line is the top function, and the parabola is the bottom function from -2 to 1. So line is the top. -x plus 2 minus 4 minus x squared dx. Then we're going to add, and I would write this on the same line if I had room. Go ahead. -2 to -1. Not 1, -1. Then from -1 to 2, now they switch places. Now the parabola is the top function and the line is the bottom function. 4 minus x squared minus -x plus 2 dx. And then plus the integral from 2 to 3, I think. Yep, 2 to 3. The line now is the top function. Parabola just became the bottom again. So -x plus 2 minus 4 minus x squared dx. Now that's going to be a lot of work. If it's on the non-calculated part of the test, you better be able to you better be able to do this by hand. However, it's all polynomials. I don't think anyone would say, I don't know how. It's just you might multiply wrong, add wrong. That stuff happens. We try to avoid that. So I'm encouraging you to use your calculator to solve these now when it's some very basic integrals, just to save some time doing the homework. All right, here we go. Let's do it. Math. Number 9. Integrating from -2 to negative. I really want to make that positive, don't I? -1. -x plus, it even takes a long time just to enter it in the calculator. -4 plus x squared. dx. Enter. Plus math, number 9. 9 is integral, 8 is derivative. You can evaluate derivatives too. -1 to 2 of 4 minus x squared. How about we do plus x minus 2? All right, we got that. And then finally plus math number 9, 2 to 3 of -x plus 2 minus 4 plus x squared dx. And we'll go math, change it to a fraction, 49/6. That change into a fraction is the first thing under math, under the math menu. Find the area of the regions enclosed by the lines and curves. So we're finding the bounded regions. So I had a student come up to me in first period. She said, which one is the right one, which is the left one? Now remember, you're looking for the bounded region. You're looking, and interesting little story. I took Calculus 3, and we were finding areas of bounded regions using calculus, of course. And most of the time, you assume the x and the y axis are boundaries. That's not always the case. So a professor wrote a test, and he forgot to include the x-axis. So what appeared to be a bounded region ended up being an infinite region because he forgot one of the boundaries. Well, some people picked that up, some people didn't. I didn't. I was the one that didn't. So I found an answer that he kind of wanted that answer that we gave. But he comes back the next day and he goes, well, you guys, that was supposed to be bounded. Some of you caught it, some of you didn't. Because of that, we're going to have to give the test again. So we took the entire test over because he left off one of the boundaries. Didn't make me happy, but that's college. They don't care as much as we do. They're like, you got a problem with it? Is your check cleared? That's all I care about, you know? Did you pay for tuition? Okay, that's what I'm worried about. We're taking the test over again. So anyway, that left a scar on my soul. X minus y squared. if we're to solve for y, it's kind of a mess. Because now I'd have to integrate both plus and minus the square root of x. I don't want to do that, because there's a much easier way. Let's solve for x. So if x equals y squared, x equals 3 minus 2y squared. I know what these graphs look like. Y equals x squared is a parabola that opens up, so x equals y squared must be a parabola that opens to the right. That's this one right here. Now for the other one, if you plug 0 in for y, you get 3. 1, 2, 3. And when you have a negative y squared or a negative x squared, that parabola either opens up down or to the left. So this one opens up to the left. Now, let's say you're looking at the equations and you don't know what it looks like. Grab your calculators if you have it today. I'd play along on this one. It helps. If you go to mode, one of your choices is parametric. Let's go to parametric. Go to y equals. And I have stuff in here already. Let's clear this out. Now this says x equals y squared. So in the x, you got to put t squared. And then in the y, you just put t. Then for the other one, we have 3 minus 2 t squared. And in the y, you put t. Now this is if you have no idea what these graphs look like. I can graph these, maybe you could too. The problem with parametric is the window is usually set up for, if you look at your window, it probably says 0 to 6.28. This is set up for trig functions. That's what it defaults to. So we have to change ours to we usually do negative 10 to 10s. Step 1, I might have to change that. Negative 10 to 10. Negative 10 to 10 is what we need. Now yours should, if you haven't ever touched yours, yours should say negative 10 to 10s. But I'm curious, what is the step? Yours is step 1. Are all of yours step 1? Oh, 0.13. I like that better. Let's just go 0.13. That's some version of pi, I'm sure. Let's see what that looks like. Graph. There we go. And it gives you a nice graph of it. Now you can tell which one's the right one, which one's the left one, because I haven't mentioned that yet. We're going to integrate from we're going to integrate the right function minus the left function. But instead of integrating along the x-axis, we're going to integrate along the y-axis. So we have to find out what are we integrating to. So we're going to set y squared equal to, I don't need two equals, y squared equal to 3 minus 2y squared. We're going to find out where these intersection points are. Add 2y squared, that's 3y squared equals 3. Y squared equals 1, so y equals plus or minus 1. Now if we're integrating right minus left, we're really integrating along the y-axis. Integral from negative 1 to 1. Oh, I can do this. Are we convinced that this is symmetric over the x-axis? Yeah, I am too. I'm convinced it is. It didn't seem to move up and down. The x-axis seems to split those two parabolas right in half. So I'll go 2 times integral from 0 to 1. And I'm going from this 0 to this 1 right here along the y. I'm not integrating 0 to 1 on the x. Right function minus left function. So 3 minus 2y squared minus y squared. The red is the right function, the blue is the left function. Now when we integrate, we're finding the area all the way to the y-axis. So I'm taking all of this area, minusing out all of that little area right there, leaving the area in between. So 2 times integral 0 to 1, 3 minus 3y squared dy. 2 times 3y minus y to the third. 0 to 1. 2 times 3. Wait, did I integrate already? I'm losing focus here.
Yes.
I integrated already. So 2 times, I was going to integrate again. What the heck? 3 minus 1. Minus, I'll even write it this time, 0 minus 0. So 2 times 2, 4. Go ahead.
So why do you have to put it in the parametric function? Why doesn't it work in Y1 and Y2?
Okay. Let me ask you this. If I have the equation, x equals y squared plus 2y minus 6. And we go to function form, the normal form. Go to y equals. What are you going to put into y equals?
It won't work if you just like change the x's and y's.
For sure it will. X squared plus 2x, well, yeah, if you do it right, x squared plus 2x minus 6. Now remember, this is a parabola that opens to the right. So if I graph this, it looks something, I don't know exactly where it is. It's something, it's like, it looks like that. But when we graph this one,
Oh, okay.
it's not going the right way. Now, if you can visualize turning it, that'd be great. But I don't want to think that much. I think if we just do parametric and look exactly what it looks like, I think that's much better. Anything else? All right. That should do it for this.